In this video, we're going to look at an alternate way to find the remainder when two polynomials are divided. But let's begin just by starting with what we know. We have two polynomials we're dividing here, and so to get the remainder we can use long division, and if our divisor is of the form x minus a, we can use synthetic. So I'm going to use synthetic division here. A equals 2, so 2 goes in the box. And then I put my coefficients for my polynomial p of x down in order from highest degree to lowest. So degree 4 has a coefficient of -3. And then we have 0x cubed, so the coefficient is 0 on the cubed term, 0x squared, 0 on the squared term, coefficient of 1 on the x term, and -7 is the constant. And doing synthetic division, bringing down the -3, multiplying by the number in the box, adding, multiplying this number and this number, -12, adding, multiplying, adding, multiplying, adding, and we know that this is the remainder. Now the reason we're beginning to focus in on remainder in this question is that if you do get a remainder of 0, which we didn't in this question, but if you had gotten a remainder of 0 when dividing this into this, it would have meant that your divisor was a factor. When you don't get a remainder of 0, then you know that your divisor doesn't divide evenly, it's not a factor. So moving forward, we're going to find that finding the remainder, knowing whether it's 0 or not, is going to be an important thing. And so we can find our remainder by division, or synthetic division in this case, but are there other ways that we can come up with the remainder? So what I'm going to do is go back to my division statement, which remember says that your polynomial is equal to your divisor, which in this case we're talking as x minus a, times your quotient plus your remainder gives you your original polynomial. Okay, that's our division statement. Now I want you to watch what happens when I plug x equals a into the division statement. So x becomes a. Every place I have an x, I'm replacing it with an a. And I'm going to get a minus a, which is 0 here, and 0 times anything is 0. And what I'm left with is that p of a is equal to the remainder. And this is a very powerful statement because what it's saying is that if you divide x minus a into p of x, the remainder you get is the same value as simply plugging a into your original polynomial. And that result is called the remainder theorem. If you have a polynomial and you're dividing it by x minus a, then your remainder can be found by dividing, but it can also be found by evaluating p of a. All right, let's just use the example above and show how the remainder theorem could apply here. So I have my polynomial p of x divided by my divisor of the form x minus a, where a is 2. So what we're saying is that the remainder, when the polynomial is divided by x minus 2, can be found by evaluating p of a, which is p of 2. In other words, just put 2 in for x here, (2 minus 2 to the 4th is 16 times 3 is 48. 2 minus 48 is -46, minus 7 is -53. You'll notice that the value I get for p of a is the same as the remainder. That's the remainder theorem. I can get the remainder without actually dividing. And by knowing the remainder, I know that my divisor does not divide evenly into my polynomial. In other words, it's not a factor. Here's a different example. We want to find the value of k if the remainder, when our polynomial is divided by x plus 1, if the remainder is 0. So we know that our remainder is going to be 0, which means that if our remainder is 0, x plus 1 will divide evenly into our polynomial. In other words, it's going to be a factor of our polynomial p of x. So p of x is the polynomial, is our dividend. So we're just identifying what all the pieces are. And the remainder theorem says that the remainder, when the division is done, is the same as the p of a value. And our a value, x minus a is negative 1. So that's going in here, and our remainder is 0, we're told. Alright, so all we need to do to find the missing value of k is apply p of negative 1 to this. In other words, putting negative 1 in for x will give me an output of 0. So 0 equals negative 1 cubed minus negative 1 squared plus negative 1 times k minus 8. Negative 1 cubed, negative 1 squared is 1, so it's minus 1, minus k minus 8. So that would be 0 equals negative 10 minus k. In other words, k is negative 10.